Hey, hi. So today I'm going to explain the one of the famous topics like BST implementations. So BST implementation, it means that every BST have the rules, as we know that left side of the property is that left side of the node, it will be always the less than the root node, and right side of the node is always will be greater than the root nodes. So this is the property which is the BST property whenever we are going to implement. So now whenever we are going to implementation, then the one is the insert means during the insertions we have to see how we follow this rule, left child and right child rule. Then after that we'll implement the min max. Definitely whatever the leftmost node is, it will be the minimum node, and rightmost node, it will be the max node in the BST. Delete and search node, and then after that in order traversal. So these three things we will see. So idea is same. How we can do it, like we have this is the node example as, and in the beginning whenever we are going to insert in recursively, nothing but we will try to find out the position of the nodes. In the beginning, if the node is null, suppose that, then we will put the x element here. Now whenever the next element will come, then recursively we will search in the whole the existing array that if it is less than or greater than, and based on that till the end of the nodes will reach, and then after that what we will do, we will attach that node into the specific location. Suppose that this is the location which we found, and adding node which we want to add it, it is the greater than left also. So in that times, this is the, suppose that this is the parent and this is the left node. So parent dot right equal to new node it will be. Similarly, in the vice versa, suppose that this is the node, and we are searching. This is the parent. This is the right node, and the right node is greater than the whatever the data we are going to insert. So in that case, we'll insert the data here, okay, and or here in this right side, okay. So I hope so you got it. So this is the way through that we can insert the data, and we found the recursive position of the node where exactly it will fit, and will put the data. Will link, basically we create the node and point to the left or right nodes of the parents. So based on the condition, right? So that is a insertions. Minimum node, how you will find out. So minimum now node again is nothing but you have to traverse till root dot left not equal to nulls, and then if you will reach, then whatever the root data is there, it will be the minimum node. Similarly for the maximums, always you have to traverse the right in the right subtree, right, recursively. Suppose that there is a node, there is a node, there is a node, so recursively you have to reach in the traverse into the right side, and where the right side it will become the null, that will be the maximum node. Okay, for now for the search and delete, the same operations. Search node, it means that again since we construct this tree based on the BST property, so according to that we will search left side or right side of the data, and we'll try to find out. Delete nodes. Delete node is nothing but moment whenever you found the position that this is the exact position which we have to delete it. So in that case, nothing but you have to point to the left side mode, right? Left side subtree to the current node, parents, okay, of the nodes. So let's jump on the code how we are doing here. So if you will see, this is the BST, and here if you will see, we are inserting it. Here the iterative approach I am doing, but recursive approach also we can perform. So in the iterative approach, what I am doing, if the root equal to null, then in that case our BST it will be the blanks. So in that case we will attach root node equal to new node. Okay. Otherwise, what we will do, if this data, this root equal to not null, that means that we will put into the current and parent equal to null, and inside this while loop, what I will do, inside this while loop, always the current I initializing to the parents, and will search it key how the data, if whatever the data which we are going to insert, it is less than the current dot date, then it means that we will move into the left side, and after the moving the left side, suppose that this particular left movement is null. If movement is null, it means that we have to create the new node and attach to the parent of left, since this is the null, and we will return it. So with this while loop it will return, it will break. Now similar condition is that if suppose that data is greater than or equal to might be, so in that case what we will do, current equal to current dot right, and if the current equal to null, then we have to create one node and attach to the right nodes. So this is the conditions where I can do it for the insertion. Okay, so this is the insertion. Minimum node, like I explained, recursively we will go to the left side always. Okay, so if root itself is not equal to null and root of left not equal to null, then recursively we have to call, otherwise I have to call to the return to the root. That will be the minimum. Similarly in the maximum, like as per the property of the BST, rightmost node always will be the greatest one. So that's why here in this condition I traversing through the right, otherwise I returning to the root. Now search operations, again, if root equal to null, during the search, if at any place if you found that root equal to null, then it means that there is no exact found we got, right? So in that case we have to return the false, otherwise we move to the this condition, right? Means if data is found, then true, otherwise based on the current data and the value which we are going to search it, according to that we will either move the left move or right move. Okay, this is recursive approach which are doing. And similarly, if you will see the delete the node, right? So node deletion is how is happening. Like I said, key first we have to see the position, right? Position, it means that if suppose that is you not found anything, data is not found with the value, then basically you have to move the left or right according to the situations. And if these two condition is false, then it means that data we found the data, and whatever the data if we found their left and right equal to itself is the null, then there is no point to do anything. So in that case we have to attach the root equal to null itself, whatever the current is there. Okay, otherwise, because in this case root is nothing but the current node basically. And similarly, if the left equal to null, then in that case left equal to null, it means that whatever the root data we have to remove it, because current itself is the node which we have to remove it, right? So in that case we have to replace the root with the right side of the node, because left is the null. In case of left right is the null, so in this case left will be the replacement of this current node. Okay, this current node. And if suppose that out of these two nothing is there, means we have the data of the left and right side, both sides. So in that case we will found the minimum nodes, and that minimum node will attach to the this current nodes and will pass to the deletion of the this data to the recursively to the next node. Because you got it right. It means I am saying ki scenario. Suppose that there is a scenario. See, here is like this, right? Suppose that this is the data. Just I am not keeping the value. Just any think in mind that there is some data is there in a attached with the every nodes. So I saying ki there is the, suppose that this is the node which you want to delete it, right? And since there is left or right, both is not the null. Left and right is not the null. So in this condition it will be reached to the here. So in this case we will try to see the into the right side. Suppose that here the data is there, and into the right side we see the minimum out of this subtree. Okay, we see the minimum, whatever the minimum we will found out. Suppose that in this case this it will be the minimum node. So this minimum node data we replace here, and then again since we have to remove this one, right, till end, so we have to traverse. So that's why I saying ki we call to the next node. Okay, got it right? Because here the data I modify whatever this data is there, but now into the right side basically we have to delete all the no this duplicate data, right, which we have to replace here. So in that case be done like this. So let's see the how we will do it, like BST and BST. So minimum node, maximum node. So if you will see here, oh, sorry. So if you will see here, minimum data is a 5, maximum data equal to 5, because if you will see in this BST which I inserted, 5 is the minimum and max is the 50. Okay, now search the 5, 19, right? So 19 I am searching for that, so it will be give the true. This is the search not equal to true. If suppose that I search the 119 which is not exist, then it means that in this case we will get the false, right? Similarly, if suppose that I want to delete the sum of the node, right? Here I am deleting the 19, so before the deletion of 19s and after the deletion of the 19s, you will see 19 will not exist. It should not be exist basically after the deletion. So after deletion, if you will see here, we don't have the 19. So all these different cases is working fine. Okay, thank you.